Through what mechanism is the activity of C. elegans AGO1 regulated? You have heard about the C. elegans gene AGO1 a couple of times already. Once in the section about the forward genetic screen for C. elegans mutants with defects in cell death. And the screen identified N1162, a loss of function mutation of Z4. You also heard about it in the section about the reversion screen that led to the identification of Z9 loss of function mutations. And finally, you heard about it in the section about the BCL2 superfamily. C. elegans AGO1 encodes the sole C. elegans BH3 only protein or sensor with a role in apoptosis during development. Why is AGO1 called AGO1? And AGO stands for A-clain defective. Why is it not called Z, like the other components of the central pathway, like Z9, Z4, and Z3? It is because the AGO1 gene was originally defined by dominant mutations that cause a defect in A-clain, and that therefore were identified in screens for A-clain defective animals. 7 independent, dominant, or semi-dominant AGO1 mutations were identified in such screens, and these mutations all cause an AGO phenotype. Why do they cause an AGO phenotype? They cause an AGO phenotype because they cause the HSN neurons, which are required for A-clain, to inappropriately undergo apoptosis in hermaphrodites. I also mentioned already in one of the previous sections that the HSNs normally die in males, in which the HSN neurons are not needed for A-clain. Using one of the semi-dominant AGO1 alleles, N1084, I performed the reversion screen as a postdoc to identify recessive loss of function mutations of the gene. Using this approach, I identified the mutation N3082, a recessive mutation. Genetically, N3082 behaved like a loss of function mutation of the AGO1 gene. And that is because it was a dominant suppressor of N1084 and mapped to the same region on chromosome 5. And I found that N3082 causes a general block in apoptosis, just as the loss of either Z3 or Z4 does. In homozygous N1084, N3082 animals, many of the 131 cells that normally die during C. elegans development inappropriately survive. Based on its Z phenotype, I cloned the gene defined by N3082. It turned out to encode a BH3 only protein. And when I sequenced the transcription unit encoding this BH3 only protein in N1084, N3082 animals to identify the N1084 and the N3082 mutation, I only managed to find the N3082 mutation. N3082 turns out to be a 5 base pair deletion in exon 2 of the BH3 only transcription unit. This 5 base pair deletion causes a frame shift, which results in the synthesis of a truncated, non-functional AGO1 protein. To find the N1084 mutation, I sequenced the region upstream and downstream of the BH3 only transcription unit. And I sequenced all the way to the gene upstream and all the way to the gene downstream. But again, nothing, no mutation. I then started to wonder whether the two mutations, N1084 and N3082, might be mutations in 2 different genes after all. For this reason, I did some more mapping in order to see whether I could separate the 2 mutations by recombination. And I could. But they were very closely linked, only 0.04 map units, which translates into about 20,000 base pairs or 20 kb. The mapping provided some useful information with respect to the order of N1084 and N3082. The mapping indicated that N1084 was to the left of N3082 on chromosome 5. And this meant that N1084 was somewhere 3' or downstream of the N3082 mutation, and therefore somewhere downstream of the BH3-only transcription unit. I sequenced some more in that direction, but again, no success. And then I came up with a functional assay to identify the N1084 mutation. Remember, N1084 can induce an EGO phenotype in a dominant manner. I reasoned that a DNA fragment covering the gene defined by the N1084 mutation and carrying the N1084 mutation should be able to induce an EGO phenotype when injected into wild-type worms. To test this, I used PCR, the polymerase chain reaction, to amplify a 7.8 kb fragment spanning the BH3-only transcription unit and about 6 kb of its downstream region from genomic DNA isolated from wild-type animals, homozygous N1084 animals, or homozygous N1084 N3082 animals. Rather than into wild-type animals, I separately injected the 3 different PCR fragments into N1084 N3082 animals. Why did I do that? Remember, N1084 N3082 animals are no longer egg-laying defective, but they have acquired a general block in apoptosis, a SID phenotype. By using this genetic background, I could test the PCR fragments and the BH3-only transcription unit in particular for their ability to rescue the SID phenotype caused by N3082. What was the phenotype of N1084 N3082 animals carrying the 3 different fragments? N1084 N3082 animals carrying the PCR fragment amplified from wild-type animals no longer exhibited a SID phenotype, which demonstrated that the PCR fragment contained everything necessary to rescue the loss of function of this BH3-only gene. These animals also did not exhibit an EGO phenotype. In N1084 N3082 animals carrying the PCR fragment amplified from N1084 N3082 animals still exhibited a SID phenotype and also did not exhibit an EGO phenotype. This result confirmed that N3082 causes a severe reduction in the function of the BH3-only transcription unit. Finally, N1084 N3082 animals carrying the PCR fragment amplified from N1084 animals did not exhibit a SID phenotype, but did exhibit an EGO phenotype. This was great, because what it meant is that the 7.8 kb PCR fragment not only contained everything necessary to rescue the loss of the BH3-only gene, but also contained everything necessary for the N1084 mutation to cause an EGO phenotype. I quickly sequenced the 7.8 kb region that was covered by the PCR fragment, and I found a mutation in the fragment amplified from N1084 animals. At the very 3' end of the fragment, 5.6 kb downstream of the BH3-only transcription unit, there was a single base change, a G to A transition. Great, finally found. However, what I also realized is that between the BH3-only gene and the N1084 mutation, there was another transcription unit, F23B12.1, which encodes a phosphatase of unknown function. Phosphatases are enzymes that can remove phosphate groups from proteins. Since F23B12.1 is transcribed in the opposite direction compared to the BH3-only transcription unit, the N1084 mutation is actually upstream of the F23B12.1 transcription unit. Could it be that N1084 affects F23B12.1 in cis, and that its gene product, the phosphatase, then somehow affects the BH3 only gene in trans? Or does N1084 act from a distance to, in cis, directly affect the BH3 only gene? What does in cis and in trans actually mean? With in cis, I'm referring to an interaction that needs to occur on the same molecule of DNA. For example, the promoter region of a particular transcription unit is required in cis to cause transcription from that transcription unit. And for most enhancers and silencers, those regions of genes that are important for the regulation of transcription and hence gene expression, that is true as well. They need to be in cis to a particular transcription unit on the same DNA molecule in order to affect transcription from that particular transcription unit. In contrast, in trans refers to an interaction between, for example, the promoter region of a gene and the protein complex or enzymatic machinery that comes to bind to this promoter region in trans to activate transcription of the transcription unit. Interactions in trans are between different molecules, molecules that are not physically or covalently linked. Going back to AGO1, if the N1084 mutation affected F23B12.1, and if the F23B12.1 phosphatase subsequently affected the BH3 only transcription unit, the interaction between N1084 and the BH3 only transcription unit would be in trans. It could therefore take place even if the F23B12.1 transcription unit with the N1084 mutation was located on a different chromosome than the BH3 only transcription unit. In contrast, if the N1084 mutation somehow acts over the F23B12.1 transcription unit to directly affect the BH3 only transcription unit, the interaction between N1084 and the BH3 only transcription unit would be in cis. It could therefore not take place if the N1084 mutation was located on a different chromosome than the BH3 only transcription unit. The following observations strongly suggested that N1084 acts on the BH3 only transcription unit in cis. First, remember a PCR fragment amplified from N1084 animals, but not from N1084 in 3082 animals, could induce an AGO phenotype in N1084 and 3082 animals. This suggests that N1084 requires a functional BH3 only transcription unit to cause an AGO phenotype. Second, a PCR fragment amplified from wild-type animals did not cause an AGO phenotype when injected into N1084 in 3082 animals, and similarly, a PCR fragment amplified from N1084 in 3082 animals did not cause an AGO phenotype when injected into wild-type animals. This suggests that the N1084 mutation and a wild-type BH3 only transcription unit have to be in cis in order for N1084 to induce an AGO phenotype. When in trans, this is not possible. Third, N3082 fails to suppress the AGO phenotype caused by N1084 when in trans to N1084. To show this, I generated a chimeric PCR fragment that contained the N3082 mutation, but no longer the N1084 mutation. This I injected into N1084 animals, and the result was that the animals were AGO. In contrast, animals heterozygous for the N1084 N3082 chromosome are not AGO. Therefore, N1084 and N3082 in cis cause a different phenotype than N1084 and N3082 in trans. Altogether, this strongly suggested that N1084 is directly affecting the BH3-only transcription unit, and that the gene defined by N1084 and N3082 therefore were the same gene, AGO1. For this reason, the AGO1 gene is identical to the BH3-only gene. So that is all good, but what does this mean with respect to the mechanism through which AGO1 activity is regulated? The location of the N1084 mutation with respect to the AGO1 transcription unit very strongly suggested that N1084 affects the transcription of the AGO1 gene. And this meant that altered AGO1 transcription results in an altered pattern of apoptosis. Specifically, it results in the inappropriate or ectopic death of the HSN neurons in hermaphrodites. We therefore proposed that AGO1 activity is, at least in part, regulated at the transcriptional level. In other words, we propose that AGO1 activity is, at least in part, regulated through controlling the amount of its gene product, the AGO1 BH3-only protein. This was subsequently confirmed with an AGO1 reporter. AGO1 expression is detected predominantly in cells that are programmed to die during C. elegans development. Therefore, the synthesis of AGO1 protein is regulated. At the time this was published in 1999, it was quite a surprise that a mutation that was downstream of a downstream transcription unit directly in cis could affect the transcription of a transcription unit. And that in C. elegans, where things including transcriptional regulation were thought to be somewhat simpler. In the case of AGO1, the term gene becomes somewhat blurry in that parts of the AGO1 gene and cis-acting regulatory regions in particular overlap with those of neighboring genes.